Yo, 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 this is Mr. O. What's up, Mr. O here. And today we're going to learn how to solve equation on one side and both sides of the equation. Okay. So since it's a review for most of us, we're just going to keep the ball rolling here. Okay. So here are some ideas and tools that we need to be able to do in order for us to be successful in solving equation. First, we should know how to distribute clear fraction by finding the greatest common denominator. Combining like terms, adding apples and apples, bananas to bananas. Well, don't worry, we're gonna review. I'm gonna show you all these five tools, okay? And we're gonna apply them in solving, okay? So move variables from one side to the other. When we move it, we transpose it there. The opposite value has to apply, and isolating it the same thing. For example, you have 3x equals 15. You're gonna divide by 3 there. Okay, so these are the tools that you need to apply in solving equations. So here first, distribution or distributive property. Distributive property mainly happens when there's a coefficient or a expression outside the parentheses. That means you're going to multiply. And when I say think Santa, share all the gift to all the kids. Okay, here it's same thing. There's an 8 outside the parentheses. You will distribute this 8 to all of them. 8 to the 6x, we will multiply that, and 8 will be multiplied again to the -1. All right, so you do it fair share to all. So then that's how you have to solve and simplify using distributive property or distribution. The next one is clearing a fraction. When you're clearing a fraction, you have to understand that you have to find the greatest common denominator. Okay? Obviously, this happens in a fraction, and some of us have issues with fraction. The best way to do that one is identify the denominator and find the smallest number that will evenly work to all of them. Meaning to say, if I have a 1/2 x, let's say, and minus 2/5. The denominators here are 5 and 2, right? The one that works common to the denominator 2 and 5 will be what? If you answer 8, you're wrong. It has to be 10. Look, the multiples of 2 are 2, 4, 6, 8, 10, 12. What about 5 is 5, 10, 15. The smallest that goes both for them is obviously 10. So that will be your greatest common denominator. And then from there, you will multiply the problem or the expression or the equation by 10. Okay. And from there should be no fraction left, which I'll show you an example in a while. Okay, here. So I have here 1/3 x plus 4/5 is equal to 2. Okay. How do we simplify this first? Okay, again, we have a fraction, so we have to find the greatest common denominator here, and the denominators here are 3 and 5. If the denominators are 3 and 5, so what will be the smallest number or multiples of 3 and 5 that work for them evenly? The answer there is going to be 15. So I'm going to multiply the equation by 15 on both sides. Here's the tricky part. Pay attention here. When you multiply 15 by 1/3, there are multiple ways. You can multiply 15 and 1/3, that is going to be 5. But some, when the number gets bigger, it's hard to figure it out. So what I tell my kids is to do the reverse. 15 divided by 3 will give me 5 times 1, which is on top, will give me a 5 here. And you will see this will be 5x. Again, one more time. On the other side, You will multiply now, this time the 15 on the 4/5. Instead of multiplying the 15 and 4 right away, I'm going to divide it. I don't have a calculator with me, so I have to make the value smaller. 15 divided by 5 is 3, times 4 will give me 12. So this should be a 12. And then 2 times 15 will give me 30. And that will make our problem simpler in solving. And one of the clue or tools that I told you, you should be able to move things around. If I this since 12 and 30 can be like terms, so they're going to be like terms, I'm going to subtract here by 12, subtract here by 12, cross it out, drop the 5x is equal to, what's 30 minus 12 is going to be 18, and then divide everything there by 5. So my answer is x equal to 18 over 5. You cannot simplify or reduce this anymore. Some teachers might require you to have decimal value. So 18 divided by 5 is going to be 3.6. Okay? Or 3.6. Okay? Easy, right? Boom. Now let's do it one more time here. If you notice here, I have 7, 2, and 5 are my denominators. The smallest number here will be what? I have 7, 14, 21, 28, and so on and so forth. I have 2, 4, 6, 8, 10, so on. Still not. I have 5, 10, 15. The easiest one there, this could be a big number. Another way, if you can figure out is easy, simply, is you just multiply 5, 2, and 7. Multiply them. 7 times 2 is 14, times 5 will give you 70. So my greatest that I'm going to use here is greatest common denominator here, it's 70. Okay. If it's 70, again, the step that I showed you, you can follow my way, or you can just multiply. Okay. Again, you have several options. You can multiply directly 70 by 2 over 7. If you can do that one easily. If you don't have a calculator, you can just simply divide the 70 by 7. That makes it 10. 10 times 2 will give you 20. And there's an x here, so it becomes 20x. Then 70 times half. So what's the half of 70 is obviously going to be 35. And then 70 times 3 fifths. So I'm going to do my way. 70 divided by 5, it's going to be 14. 14 times 3 is going to be 42. And the rest is just basic of solving equation here, which we can do it, make it fast. So minus 35 here, minus 35 here, 20x is equal to 7 divided by 20 here and 20 there. So the answer x equal to 7 over 20. Very simple, right? Kaboom. So combined like terms, again, I mentioned a while ago, this adding apples to apples, bananas to bananas. So like terms have to have the same number of each variable type. So means say 2x and a 3y are not like terms, but 2x and minus 5x are like terms. You can combine them. Order does not matter due to the commutative property of multiplication. Okay, must be on the same side of the equal sign. Here's some example. What are like terms? So 4x and 7x are like terms. 3xy and 5yx. And these are the one I was explaining a while ago. The order doesn't matter because their multiplication is commutative, and I know this is yx, but this is xy. They are still going to be like terms. Okay, you can swap the order of the x and y there, and they're still going to be the same. Again, take note, there's no operation like a plus or minus between the x and y. The operation there is only multiplication, so that's why it should be okay. This one here is still like terms because this is x squared and this x squared. If the squared was on the y and not on the x, it's not going to be like terms. Okay, if this is 5x squared y and this is 3x squared y squared only, then they're not the same because the y here has the exponent of 1, not 2, so they're not going to be like terms. But on this example, they are going to be like terms. Okay, 7x cubed and x cubed, there are like terms here there because they both have x and a third power. In the like terms, you have to understand that you need to have the same variable and same exponent or power. Okay, so here is 7x cubed and 1x cubed are like terms, and you should know that there's an invisible one over there. So what is not going to be a like term? Like terms. So 5 and 7x, a constant of 5 and a 7x because 5 does not have a variable. Like I said a while ago, 5x squared, y squared, and 5x squared and y are not going to be like terms because this is 1 and this is 2. They're not the same. 10x squared and 10x is not going to be the same because this is 1 again and this is 2. They're not the same. That's it. Okay. All right, let's go through some basic stuff here. So 15 equals 5x. How do you solve this one? Obviously, just divide it by 5. I'm going to divide by 5 here. Okay, so variables on the left and constant on the right. Okay, that's the given basically. Oh, you can swap them. Okay, you can move the 5x to the other side and 50 to the other side, and it didn't change anything of the sign. You can keep it that way. That's okay. And then by isolating the variable, you just have to divide by 5 and 5. Take note, guys, you divide it by the item beside the variable. Take note, this is only true when you're multiplying, okay? It's a different story when you're adding and subtracting a number or a concept to the variable, okay? It goes always the opposite operation. When I say opposite operation, you're multiplying 5 and x here. When you're multiplying, what's the opposite of multiplying? Divide. So that's why you're dividing here by 5. And then this will cancel because 5 divided by 5 is 1. 1 can be imaginary in multiplication here. And 15 divided by 5 will give you x equal 3. All right. Very simple, right? Here, let's apply some distributive property. Let's work on it this time. So here we're gonna distribute 8 times negative 2 is negative 16x. 8 times negative 2 is going to be negative 16. I'm going to drop the negative 112 here, equal sign. Again, some textbook or some teachers, they would like to have their variable on the left side. So I'm just going to move or flip them all. Negative 16x here minus 16 is equal to negative 112. Okay, so we can combine the like terms here. If we combine the like terms, I'm going to add 16 here, add 16 here, and then 112 or negative 112 plus 16 is going to be 90, negative 96. And this cross out, you know that. Drop the negative 16x. And then from here, you're going to divide everything here by negative 16. Take note, this cancel out. Both of negative, so this was just going to be x. Negative divided by negative is going to be positive, and 96 divided by 16 is going to be 6. Okay, very simple, right? Let's go here. For this one here is very simple. I know that we have a fraction, but this is 1, that's 4. There are multiple ways. If I can combine these two because they're like terms, I would do it that way. So x over 5 minus 3 equals 4. Since I combine 3 and 4, I can add 3 here, add 3 there. X over 5 is equal to, what's 3 plus 4? It's 7. Now I can multiply them all by 5. Crosses out. X equal to 35. Okay, very simple, right? Let, let's now go to solving equation when there's a variable on both sides. Same thing applies. You have to distribute, you have to clear the fraction, combine the like terms. You can move it from a term from left to right, and you should be able to isolate the variable. Okay, so in this case here, I'm gonna work it out for you guys. Okay, so I see a parenthesis, so I can distribute. So this will be negative 5x 40. Remember, you multiply the negative 5 to the x, negative 5 to the negative 8 becomes positive 40. And I will just drop negative 7x plus 28. Just a reminder that you can combine the like terms here by identifying the like terms first. I can see that these two here are like terms, right? So I'm going to move one of them. And ideally, they suggest that all the variables that you're solving for has to be on the left side. So I am going to add the 7x here. Why is that working? Add 7x, add 7x here. If I do that, sorry, cleared it out, clear. Okay, there you go. Cross it out. This will give me 2x. And you know I can subtract the 40 here, subtract the 40. Okay, just remember, guys, that the term with the variable and the one without the variable, between them should be the equal sign. Some kids, this is a common mistake, okay? Some students, what they do is that, oh, will I subtract 28 and subtract 28 here? Or should I subtract 40? Okay, always look where is your equal sign. The equal sign must be between them. And my equal sign is right here, so I'm going to put equal sign here. So I need to move the 40 to the right. And this will give me negative 12, right? Right. And then you know how to solve it from here. You divide everything there by 2, by 2. Take note it's negative here because 40 is bigger than 28 and 40 has a negative sign. This cross it out, so therefore x equal to negative 6. Very simple, right? Kaboom. Okay, let's go with the fraction. Let's go with the tough one here. Okay. I see here fraction. Okay. Negative 11 over 18 plus 1 third x equals 3 halves times 7 third x plus 1. I see a fraction there. I see 3 halves. So what are you going to do there? First, you can distribute the 3 halves. When you distribute the 3 halves there, remember, when you're multiplying fraction by a fraction, numerator times numerator, denominator times denominator. So 7 times 3 will give me 21. 2 times 3 will give me 6. So that's why I have 21 over 6 here. 3 halves times 1 is going to be 3 halves. And if you notice, everything on the right side of the equation, I just drop them down. Okay, don't worry about it. Now, you can combine any like terms, but ideally, you have here a denominator, 18, 3, 6, and 2. And the greatest common denominator here will be 18. How do you know it's 18? You know, some of you probably have a question. How do you know it's 18? Why do you get it too fast? Okay, let's write it down here. 18, factors of 18, 18, 36, and so on and so forth. 3 will have 3, 6, 9, 12, 15, 18, 21, 24, and so on. 6 will have 6, 12, 18, 24. And 2 is obviously 2, 4, 6, 8, 10, 12, 14, 16, 18. With all of them, what's the common? The common is 18. All of them have 18. So that means the greatest common denominator there is going to be 18. And that means you're going to multiply 18 to all of them. And I showed you a while ago, it's simpler this way. For me, if I'm not using calculator, 18 times negative 11 over 18, I will always divide it first by the denominator. If I do that one, 18 divided by 18 is going to be 1 times negative 11. The answer here is negative 11. Let's see. I'm right. There you go. And then how to get the 6x here, I am going to multiply 18 by 1/3, or divide 18 divided by 3 is 6, times 1 is 6x. Same thing here, 18 divided by 6 is 3. 3 times 21 is going to be 6x. Sorry. 18 divided by 6 is 3. 3 times 21 is going to be 63x. And 18 divided by 2 is 9. 9 times 3 is 27. There you go. And from here, you can just solve the equation by combining the like terms. And again, ideally put the x on the left side, so you subtract 63 here. 6 minus 63 will give you 57x negative 57, because 63 is bigger technically and numerically. Drop the negative 11, drop the 27, and I'm going to move the negative 11 to the other side. So by adding 11 on both sides, so drop the negative 57, this will give me a sum of 38, then divide them all by the negative 57. The answer there is negative 38 over 57. And you can see that you can still simplify your answer, reduce your answer all the time as much as possible, especially in your final answer, to get the full credit and the correct, accurate answer. Okay, there you go, folks. We have solved linear equation on one side when there's a variable on one side, on both sides. Okay, this should be very easy, and I hope you learned something. Again, this is Mr. O. Kaboom.